Stanford University.
All right, let's get started. Welcome again to Lecture 8 for CS193P. We're about to talk about table views today. We have a special guest, actually, from Apple UIKit. Jason Beaver is going to be talking, so I'll introduce him in a bit. Sure, round of applause. Right. And special visitors today. We have the Atlanta Girls School visiting and sitting in on the class. So a few announcements before we get started. First of all, Presence 1, the assignment for Presence 1 is due tomorrow, so at 11:59, be sure to have it in. Any questions on Presence 1? There's actually one thing I want to cover before I get into questions, which is we've had a lot of people ask if you have 3 buttons, do you have to have 3 actions to handle each person, right? And one hint that I'll give you is you could use a property on UI view called tag. And tag is basically an integer, and it just lets you identify each of the buttons. So consider using that. And as you're implementing, if you still haven't done Presence 1, consider setting that tag property on each of your buttons and then figuring out how to look at that when you get your action. So any questions on Presence 1 before I go on? Yeah. Question is it okay to have each person have its own UI view controller? And I would encourage no. If you can. So Evan says, sure. If you think you need to. The thing I'm trying to discourage is if you don't create 3 different UI view controllers for each person. One thing you should be trying to do is how do you figure out how to reuse those UI view controllers for each of the different people. So and that's going to make more of a difference in Presence 2, which is due next Tuesday on Cinco de Mayo. So plan ahead if you're going out next Tuesday night. Get your assignment in early. Don't blow your late days because you're, yeah. Anyway. So the third thing I want to say here is that we have loaner iPod Touches. For anybody enrolled in the course that has requested one in the survey, come see us. You're going to need your Stanford ID. And we need to get it back before the course ends, or else you won't get your mark. So come today after class. We have a big box hidden somewhere, because otherwise you'd pounce. But yeah, after class today, we'll give it out. And I think if we miss today, we'll probably do another day, but arrange with us separately. So end of day. So now, without further ado, I want to introduce Jason Beaver from the UIKit team. Actually, sorry, Jason. Any other questions from last week? Any questions from last week's assignment or last week's lecture or anything like that? No? Okay, good. You can ask Jason if you have any. All right, Jason.
So, as you mentioned, I'm Jason Beaver. I work on the UIKit team. I work on table views and multi-touch and an accelerometer and a few other random little things. We're going to talk about scrolling today, though. As you know, the screen's fairly small on these devices. You can't get a lot of content on there. You need some way to be able to scroll that, and virtually every app on the system makes use of that. So we're going to start out talking just about the basic scroll view class. And we'll talk about table views, which are a subclass of scroll view, how you can get data in there, control some appearance. And then table view controller, which is a subclass of UI view controller, which helps you manage a table view and some of the automatic behavior you get as you transition between screens. You've seen like push animations in a lot of the apps. Table view cells, which represent each row inside a table view, and we'll explain a lot about how you control appearance and behavior of those. And then I guess there'll be something about presence too. So let's start with scroll views. As I mentioned, they're for displaying more content than can fit on the screen at any one time. It automatically actually handles gestures for panning and zooming. With a single finger down or even 2 fingers moving together, you can pan the content left, right, up, and down. And by pinching, you can scale the content up and down. Table view is one of the subclasses. We also have text view, which is another subclass of that. So here's a few examples. The Maps application uses one of those to let you scroll around the map and zoom in and out. The Photos application, same idea. And the Notes application lets you scroll up and down within the content. There's a couple of table view examples. Here's one from the iPod app and also from the World Clock. So to use one of these, we first just need to create one, and you need to specify where it lives on the screen. You do that by initializing that with a given frame. And then you can add subviews wherever you want. Here, for example, we've added an image view with a larger frame than the scroll view. It's an image view that's obviously much bigger. You want to be able to pan around in it. And then we need to tell the scroll view how big the content area. This specifies how much you can scroll before you hit the edge, and scroll view forces you to stop. So in this case, we'll set it the same size as the image view. So visually, how does this work? Scroll view has some frame that represents what you see on the screen. The content has some area that represents an area that goes off the screen. And there's a content offset property on the scroll view that lets you position that window in the content wherever you'd like. So let's jump to a demo of using this. So we have a simple application here that in its application did finish launching creates a scroll view, sets itself as a delegate. We'll get into what that does in a minute. We set the bounces zoom property. This is the property that when you get to the end of a scroll view and you keep pulling, it sort of pulls past the end, and then when you let go, it sort of springs back. That property gives you that behavior automatically. And then we'll set the background color. Any areas that you're not completely occluding with subviews will show this background color. We'll create a container view to put inside it. And then we're going to add several image views. We're going to load images named, creatively enough, 1, 2, and 3. And create an image view that's the size of each of those images. And add those to the container view. And then once we know how big all those are, we'll adjust the container view's frame to contain all of those. And we'll set the content size to the size of the container view. And if we run this, so you have a scroll view, and it has several photographs in it. And I can scroll left and right to see those. And here, if I come down, there's a second photo and a third photo. Yeah, lovely. All right. So there's a few things you can do to interact with a scroll view or control the scroll view's behavior. You can find out when the content offset is changed. If you need to, for example, instead of creating all those subviews ahead of time and populating them, to be more memory efficient, you might want to create them only when they're going to appear in the visible region. So you can know when the scroll offset changes, find out if one of those image views intersects the visible region, and then add it then. Find out when dragging begins and ends. So this is when the finger actually is on the screen, not when you release and it's smooth scrolling is a separate thing. That's when the scroll offset is changing. But you can find out when the user's finger is actually down on the screen. And then you can find out when the deceleration begins and ends. That's when you push and then release, and that the scroll view sort of coasts to a stop. So there's a couple ways to extend this. We can extend with a subclass. So you would obviously create a subclass, and you can override whatever method you want to customize the behavior. But there's a few issues with this. You've now bound your application logic up inside a view instead of keeping the nice model view controller paradigm. And you have to write new subclasses anytime you want to change the behavior, which gets kind of tedious. And your code becomes tightly coupled. If it's, in this case, it's bound to a scroll view, you can't use it as part of any other class. The other way to do it is through delegation. And I don't know if you guys have covered delegation at all, but with a delegate, obviously, you can easily extend a class without having to subclass it. So there's a few clearly defined points of responsibility with scroll view that allow you to change the behavior and customize the appearance. And this allows you to write code that's loosely coupled with the scroll view. Scroll view delegate has a protocol. There's some optional methods on there. One is scroll view did scroll. Whenever the content offset changed, you'll get a callback for that. There's one also, we're skipping obviously a few, but there's one to control behavior. This is scroll view should scroll to top. One of the sort of hidden features not everybody knows about is that you can tap on the status bar in any application, and the primary scroll view will try to scroll to the top. the delegate kind of control that behavior. So to implement a delegate, you just need to conform to the protocol. That's the syntax for doing that. You have to implement all the required methods and whichever optional methods you like. So in this case, we've added the optional method scroll view did scroll, and we can do whatever we'd like at that point. Check the content offset and, for example, add in a subview or take out a view that's not visible anymore. To zoom with a scroll view, we need to set the minimum and maximum zoom scales. This lets you specify how much you can zoom in or out. So in this example, we've set the maximum zoom scale to 2, so twice as big as whatever content size it is. And then the minimum, in this case, is so that the image just fits on the screen. Then there's a delegate method to specify what should be zoomed. When the scroll view handles one of those pinch gestures, there's some view that's going to get a transform applied to it. This is how the delegate tells the scroll view what view should get that transform. So let's look at a little demo here. So as I mentioned, we need to set the minimum and maximum zoom scales. And we've already implemented this delegate method view for zooming and scroll view, and that returns the container view. So with just that change, can still pan around like we could before, but now with 2 fingers down, we can zoom in and out. So we can zoom up to twice as large as the image was initially, and we can zoom all the way down to the point where the image fits on the screen. And notice that springs back out. That's also part of the bounce zoom behavior. Oh, I'm sorry. If you hold down the Option key, you get 1 finger underneath, or 1 touch point underneath the cursor, and 1 opposite of the center of the screen. There's even another behavior. Let's see, which is it? I forget. Yeah. So if you press the Option key to get that up, and then press the Shift key, they'll move in parallel. So if you want to use 2 fingers to, pan like that, or if you need some other 2-finger behavior, or you want to do the pinch somewhere non-centered, I guess. Okay. Any questions on that? Okay. So let's move on to table views. As I mentioned, table views one of probably the most commonly used subclass of scroll view. It's for handling the common use case of a list of items of some sort. It's a single column, as many rows as you'd like. There's probably some upper bound that I've not run into, but, and only handles vertical scrolling. There's no horizontal scrolling within a table view, and it is designed for extremely large data sets and efficiently handling those data sets. And it's pretty common, as I mentioned. You've probably used it a lot of places. So table view comes in 2 basic styles. There's the plain style, which has cell content that goes edge to edge on the screen, and the group style, which has rounded rectangles separating each section. There are several components in a table view. There's a header that exists at the top of the content, and a footer that exists at the bottom of all of the content. There are multiple sections. Table views don't have to have multiple sections, but commonly do. So in this case, we have a couple of sections. Sections have headers and footers, and then there's some number of rows. Each row is drawn by a table cell. So this is what it looks like in a plain style. If we go over to the group style, all the same pieces are there. They look a little different, and you get all that automatic display, all that appearance for free just by switching the style of the table view. So, displaying data in a table view. So a simple solution would be to just hand the table view a big array of stuff and say, here, display all these things. For small table views, that actually might work fine, but it can get pretty expensive. You have to load everything up front if you're pulling from a database or over a network, or even just having to create objects that represent each row. That gets really expensive. And everything stays in memory. Memory is pretty precious on these devices, and we want to be pretty efficient with it. So what we do instead is use something called well, I guess I'll skip forward to the next slide there. Something called a data source. This provides data to the table view as it's needed, and it's like a delegate, purely data-oriented. So like I said, it's the data source. So the table view needs to know a few things before it can display any content. The first is how many sections do you have, and it'll ask the data source the number of sections in the table view. And this is an optional method. If you don't implement it, you'll just get a single section. And then for each one of those sections, how many rows are in the table view? And then to put content on the screen, you're going to be asked for a cell for each one of the rows that's visible. If you have a lot of rows, obviously you're only going to be asked about the ones that intersect with the visible region of the table view. And as you scroll, the moment the first pixel would become visible, you're asked for that cell, and expected to return it pretty quick. I'm sorry? Yeah.
Back one slide.
Sure. Here?
No, the
Here?
The one that's like you have to set how many rows per section.
Yes.
I thought if you have like different sections, it would be the number of rows.
So this is, you're passed in the section that the table view is asking about. So you can have 1 row for section 0 and 2 rows for section 1. Sure. Any other question? So visually, what does this look like? Table view will ask the data source how many sections. The data source in this case is going to return 5. And the table view for each section is going to ask how many rows. So here we're asking section 0. The data source is going to say 1. This will be repeated for all of the sections. Once we have that, the table view now knows that the row in section 0 there is visible. So it's going to ask for a cell for that. So it's going to ask what to display. The data source is going to return a cell with some content, in this case, John Appleseed. So the way we specify cells is using a class called NSIndexPath. It's a generic class in Foundation that specifies a series of indexes that define a path in a tree. TableView uses it in a very specific way to specify the section and row. And so index paths used by the TableView have just 2 entries in them. And there's a category on NSIndexPath that makes this a little more convenient. That lets you create an index path for a given row and section, and then obviously get the section and row back out of those. So let's look at a single section table view. You don't have to implement the number of sections, and so if we leave that out, the first thing you'll be asked is the number of rows in a section, and here we've got an array of strings, so we'll just return the count of that. And then for the cell, we'll create a cell, that's the ellipses here in some way, and then we'll just set the cell's text to whatever object is in the strings array at that point and return the cell. So we talked about how efficient or how memory sensitive things are on the phone. We want to be very efficient with memory. When you create a cell, there's stuff that goes with that. There are backing store layers, and it's fairly expensive to compute those and or to create those. So we want to try to reuse cells when possible, and TableView has a mechanism to do that. There is a method called dequeue reusable cell with identifier. So whenever you create a cell that has a particular layout, the icon's in the same place, the text is in the same place, so it's sort of the same form, you want to give that the same reuse identifier. That way, when you're asked for a cell, if there's already one laying around, you can just change the text in it and it's ready to return. So an expanded implementation of that TableView cell for row at index path, you would start out asking the TableView to dequeue a reusable cell for some given identifier. And only if it doesn't have one would you allocate and initialize a new one. And then in all cases, configure the cell however you'd like for display and return it. Yeah?
Sorry, in this code, it seems like all of your cells will be named myIdentifier. Is
that that's only because so the identifier really specifies sort of the style of. Oh, I'm sorry. He said in this case, all the cells have the same identifier. So how do you differentiate between them? Really, the identifier is used to specify the form or the style of the cell. If you, for example, in the iPod application, the cells all have different content, but they're basically of the same style, right? There's an image on the left, there's an album name, an artist name, and whatever. Those cells are all reusable. You have to change the image and text each time, but you don't have to recreate all the views and recreate all the backing stores and all the expensive bits.
So this is just for the layout of the cell?
Yeah. So in this case, like when we see the demo here in a second, all the cells will basically look the same. They'll just be an empty cell with text in it. You want to use the same one. So you'll be asked this, obviously, for every cell that appears on the screen. And so when a table view loads, there won't be any reusable cells to pull from. So you'll have to create enough cells to fill the screen. But then the table view will stop asking for cells once it's filled the screen. Once you start scrolling, as cells go off the top, they automatically go into this reuse queue if they have a reuse identifier. So as the next cell gets ready to come on the bottom, this method will get called and you'll be able to pull that out of the reuse queue and return it. And so once you've populated enough to fill the screen, typically plus about 1, you can scroll as fast as you want and where you're not creating any cells. If you guys all have, I guess we'll have devices, when you play with this, try turning that off and you'll see just how crushing scrolling really can be if you don't reuse cells. It actually makes an enormous difference in speed. And for a complex cell, it can be as little as 20 or 30 frames a second without it, and can be way over 60 frames a second with it, which is all you'll ever get anyway. So when is the data source asked to create one of these cells? Whenever a row becomes visible. Anytime you reload all the data, we'll throw away all the cells we have and we'll ask you to create a bunch of new ones. And there's a whole bunch of other methods you should take a look at. The headers, I forget the number, but it's a huge number of methods in table view. There's quite a lot of control you have. There's things to return the title or even custom views for section headers and footers. You can allow editing, inserting, deleting cells, reordering of cells, all the things you've seen in all the applications that are on the device. So we'll talk a little bit about, I don't know why this is here, appearance and behavior. So if you want to change the appearance of a cell, there's a callback table view will display cell for row at index path. This is after we've done all of our configuration on the cell. You can do anything you'd want at this point. You can change colors and styles and fonts and whatever you'd like. These are all things you can do without having to create your own subclass of cell. You can deal with selection changes. There's a will select row at index path and did select row at index path. The will, notice, has a return type of index path. This lets you change the selection if you want. If somebody taps on one row, you can actually cause a different row to select. So in iPhone applications, it's pretty uncommon to leave a row selected. There's only a couple of places we do this internally. And in the 2.0 version of the SDK, it isn't actually officially supported to leave a row selected. Usually, selecting a row triggers some action or event, and then you're expected to deselect the row and it'll fade out. So here's a little video. We've clicked on all contacts there. We've clicked on something that's caused actions of pushing in a new view controller. And then I think the video for some reason didn't show it, but table view controller automatically manages fading that selection out when you hit the back button. So if we're going to do something like that where we've got a navigation hierarchy, in our did select row at index path, we'll get the row, the object it represents. So ask the index path for its row, find out what object in our model that represents, create a new view controller, set up the object, and then just push that view controller onto the stack, and that'll automatically do the animation that you saw. Here we've also optionally implemented the will select row at index path. If you want to do something like prevent a given row from being selected, you can do that here. There's other ways to do that, but this is one way to do it. So let's look at table view controller. You can obviously manage a table view all by yourself, but when you're trying to use it in a fairly normal way in a navigation-based application, a table view controller gives you some automatic behavior for free. And certainly as we add things in the future to, I don't know, control table views, you'll get that behavior automatically if you use a table view controller. The table view controller acts as the table view's data source and delegate. And it takes care of some of these default behaviors. Whenever a view comes on screen, it reloads the data. As I mentioned, when you navigate back in a hierarchy, it'll take the row that was selected and animate out the selection. And it'll flash scroll indicators when you first make a table view visible, so the user has some context where they are in that content. So let's do a table view demo. So this is I think a simple navigation-based. Oh, it's not even nav. Okay, so this is just a real simple view controller-based app. So my table view controller here is a subclass of the UI table view controller, and the designated initializer on that is init with style. So we'll override that, and this is the place where we will create our content, and here we'll just have a little array of names. When we're asked for the number of rows, we just need to return the count of objects in that array. And then when we're asked for one of the cells, we will attempt to dequeue a reusable cell with that identifier. And if that doesn't work, we'll allocate a new one. And then just as we saw in the sample before, we'll set the text to whatever string's in our array. And let's just start with that. Cannot launch simulator. Great. So there's our simple little array of things. And like I said, we can scroll automatically, just like you'd expect. There's no horizontal scrolling. These are obviously pretty simple cells. We've got a little bit more code in here to handle selection. In this case, we'll implement the did select row and index path. And we'll just throw up an alert view saying, hey, you selected some row. You obviously can do anything you want to do with this. But let's see what that looks like. If I click on one of these, you get the little pop alert. Notice you automatically, should mention here, the last row tells us to deselect that row, and the last argument is animated. That causes the selection to fade out. And if you watch carefully as I click on one of these, you'll see the selection fade out as that alert's popping up. All right, I had one other little thing up here just to show you what it looks like with a lot bigger data set. This actually gets all of the known time zones, sorts them, and hangs on to that. Yeah, sure. So obviously you can see you automatically get the scrolling behavior, the deceleration behavior, and we're using table view cells, so even on a device this would be very fast.
What's the size of the data set that you used earlier today?
Oh, I was playing around with it just to see how large the table view is, and this was on a simulator, not on the device, but I was playing around with 600,000 rows, which on the desktop is still basically instantaneous to create a data set that big. And even without cell reuse, it behaves fine. The memory use goes up pretty quickly, but on the device, you'd find out that was really painful. I think when I did testing on the device before we shipped 2.0, just creating a table view with 80,000 rows in it was several seconds before the table view even got the first cell on the screen. It was fast once you did that. Scrolling was normal speed, but anyway.
How do you get the alphabet on the right-hand side of the page?
So there's a method to return the set of characters to use. I'm sorry, I keep forgetting to do that. How do we get the index that's over on the right, like in the address book? You see A through Z. So there's a method to return the array of section index titles, and those are it's an array of strings. Generally, you want those to be 1 or maybe 2 characters. And then there's another method to optionally control the mapping between those things and the sections in the table view. For example, if you have a table view that has sections A through Z and the index has A through Z, that's a one-to-one mapping. You know, the third one down will go to the third section in the table view. That doesn't work for all languages and wouldn't work for all content. There are some cases where you might only have room for, let's say, 26 or 7 things on the side, but you might have 50 indexes in your table view, and you might want the thing at index 3 to map to the section in the table index 5. There's a thing that's optional that lets you do that mapping. Whether you implement that or not, when you click on those, we'll just find that section and scroll to it, whatever section you specify. Any other questions? All right, so let's look at cells. Cells are really where you can differentiate your table view from another one. There's a few basic properties. There's an image property and a text property. So here we've set image and text, and this is sort of the behavior you see in a lot of the simple table view cells. There's an accessory type over on the right. For example, here, this is the detail disclosure. This is the little chevron you see. There's also a detail disclosure button. The difference between these two, besides appearance, is that in the first one, no matter where you click on the cell, you just are selecting the cell. You'll send the delegate a did select row, an index path. For the second one, only if you click to the left of this do you select the row and send the did select row. If you click directly on that, there's a separate method called accessory button tapped for row at index path. And if you play with some of the built-in apps, you'll notice that usually this takes you to detail about the object versus performing an action on the object. So for example, in the phone book app, clicking on the person's name will call them. Clicking on the detail disclosure thing will take you to detail about them. There's like I think voicemail is a good example of this. So it would take you to their card versus calling them. And then finally, there's a check mark. I mentioned selection isn't persistent typically in a table view. The way, if you want to have a list of items and have only one of them be selected, this is the way you indicate selection. It's different than desktop apps where typically a selection is some sort of background, like it is when you tap it. So cells also have a view inside them called the content view. This is the region inside the cell that doesn't include things like edit controls on the left and reorder controls on the right and those accessories we saw. And you can add whatever views you want. This is just a standard UI view. You can use the add subview method to add anything you would like. So here in the cell for row at index path, we're allocating a label and adding that into the subview. And we can, obviously, using the init with frame, we can control exactly where that label is. We can customize its font and foreground and background colors, whatever we'd like. Table view also has the ability to support custom row heights. There's a delegate method to customize that. It's called table view height for row at index path. And if you implement this, you'll be asked about this for every row in the table view. You can do whatever height calculations you'd like. One caveat is this is called for every single row in the table view at load time, even rows that are not visible, so that we know how big the content area of the scroll view is. So this needs to be pretty fast. Here, example, we're trying to size some text, so we're creating whatever string we would like and using this size with font method to figure out how tall that would be and then returning a height plus whatever padding we'd like. And that's really it. That's all I've got. Any questions? The question is that content view that's inside the cell, is that just the size of that label or is it something bigger? If you had no accessories or edit controls, like if you didn't have a check mark or disclosure on the right, it's the entire size of the cell, edge to edge of the screen, top to bottom between the previous and next separator. If you have accessories, it's inset by whatever amount. As you go into editing mode, that content view automatically animates to the new size. So if you put subviews of that and set appropriate auto resizing masks, which I assume you guys have talked about, when we animate in and out of editing mode, all your views will animate automatically. So the question is, can you change the height of the row? Just through the delegate method. Once you've specified that, there's no way to change the height of that without reloading, deleting that row or inserting, a new one. Yeah.
In the clock application, you said that that's a table view, right?
Right.
It looks significantly different than all the other examples.
Right. Well, let me just pull one of those up, and we can talk about what's inside one of those. Right. And I wish I could run this because it actually does something interesting when you go in and out of editing mode. But basically here they specified a non-standard row height, and there's a image view that sits in the background that draws the gradient, and the image is actually shared amongst all the cells for efficiency. There's a label over here with a shadow on it, same here and here. And then this is just a custom graphic that's, or a custom view that's drawing the clock. When you go into editing mode, unlike most of the others that just move in a little bit, the time and date actually slide out to the right as the delete buttons all slide in from the left. So all that content moves in a pretty custom way. And to do that, you actually need to subclass the cell, which we didn't really talk about, and override layout subviews. And depending on whether you're editing or not, position those views on screen or off screen. So.
Is there a background view property? I'm trying to remember how you get that gray content to draw when the edit button comes in from the side. Because that wouldn't be in the content view.
No, yeah. So there's a couple ways to do it. You can, I guess actually the only real supported way in 2.0 to do it is there's a background view property that lets you put anything you want there. So instead of putting a UI image view with that gradient in the content view, you'd just specify it as the cell's background view. Yeah.
You get for the albums one right there? Just like the letters on the side like that.
Right.
Yeah.
So that's the index that another gentleman was asking. The question was, again, about the index here. That's the same thing we were talking about before that lets you specify the index to quickly jump to sections. I believe there's another question back here.
If you wanted to create a custom background for each row, maybe generate it as a theme or something like that, what would be the process for that?
So instead of like this single gradient here, a separate thing, and you didn't have these ahead of time? In that particular case, you might have them ahead of time. If you did want to generate it, you can either just create a graphics context and draw into it, and then create an image from that and put it on the screen using all the CG stuff.
Like when you're looking at music and then you flip it on its side and it goes from this table view into like cover flow, is that just like a ton of code in that whatever auto rotate function, or like because every time you rotate it, like redraws the entire table view and then switches it over to like a cover flow thing?
Yeah, and if you want to handle this, you may know a lot more of the auto rotation stuff.
Complicated question to answer. If you want to shoot us an email at the list, we can give you some pointers in the answer for the benefit of the crowd. So the question was doing a cover flow style view where you're viewing a table view and then you rotate the device and you've got some totally different view. It's actually pretty complicated to do on the 2.0 SDK. You can maybe interpret my statement as implying that there may be some future easier way to do it. That is a question that gets asked a lot. If you're developing for 2.0, there's a lot of code you've got to write to sort of fade out one view and fade in another view. The key in that case, the UI view controller auto rotation is really geared toward having an existing view that rotates in place. So what you would actually do for throwing in an entirely different view, you would actually listen for the device orientation notifications yourself in UIDevice.h. You would listen for those, and in your notification handler, you might swap out one view for another view. So maybe in your application delegate, you would listen for UI device rotations, and when that happens, you would manually add and remove views to the window. So it's definitely not, you know, it's not like an out of the box, super easy thing to do.
Any other questions? Hey.
Can you show us a demo of, let's say in that demo you had of the table view, can you show us how easy or hard it might be to, say, delete a row?
Sure. So everybody knows, or let me repeat the question here. He was asking about modifying one of these demos so you can do swipe to delete. Is everybody familiar with this? I mean, if you're in many of the apps, you can swipe and a delete confirmation will show up. But if you hit that, the row will animate out. So let's add that in here. So to handle editing, let me actually just bring up the table view header. So to handle edits, there's a method called commit editing style. Whenever you hit the plus button on the left or the minus button on the left, which triggers the delete confirmation, and then subsequently hit the delete confirmation, that causes this method to get called to commit that either insert or delete. So we need to handle this method. And I'll just copy this implementation over here somewhere. And let me so let's look at the arguments of this. You're obviously told about the table view. You're told about the editing style. And then you're told about the index path of that row. We're going to assume the editing style is going to be delete for all these. Yeah, that does need to be mutable, doesn't it? I'll just do this with this one.
You can just do mutable red.
Yeah, that's just what yeah. Right.
This is the part of the lecture where we make jokes again about firing Troy from the TA position by deleting him from the table.
Right, so now we're told what we want to do here and so for a given index path. And so basically we need to do two things. We need to take it out of our model, and then we need to tell the table view to remove that row visually from the table view. So we'll first move it from the model. Let's see, those are called names. Move object. Index. Yeah, it's true. I'll fix that. All right, and then let's go back to the table view. There's a few methods here to insert and delete both sections and rows, and notice there's this row animation parameter. And if we look at the declaration of that, there are basically 5 choices. You can tell the row or section to fade in or out, or slide in one of the 4 cardinal directions. So in this case, we will, let's see. We're going to grab this delete rows at index path. Table view. This takes an array so that you can handle deletion, insertion and deletion of multiple things at the same time. And the animation that we would like is, I don't know, we can pick either direction we want here. We'll try right. And the editing style, I'm sorry, what's your question? Okay. The editing style by default should be delete, so if we we'll swipe on Evan here. Oh, you said Troy, right? Troy.
Well, you know, you're in charge.
If I had tried this before putting that method in, the swipe wouldn't have done anything. The swipe depends on that method being implemented, because if you don't implement it, obviously you can't change your model in response, so it doesn't make any sense.
That's the commit editing style.
Yeah, so the commit editing style has to be there before the swipe works. So if I press down and just sort of swipe to the right, you'll see that come up. And when I hit the delete, you'll see that slide out, and we've updated the model. In the group style, right's probably the wrong choice, because it sort of breaks the illusion of that nice rounded rectangle that encompasses all the cells. Let's try instead making it top. We didn't persist that, obviously, so I've got to redelete Troy every time. There we go. every. So you see now it actually slid up under the cell above it. And those same methods can be used to insert new cells, insert whole new sections. There's a lot of controls to animate things in and out. Yeah?
When a cell is the last in its section, you delete it. Will it delete the section as
No,
well?
sections can exist without rows. So if you want the section to go on, you have to actually delete the whole thing. And I didn't repeat the question, but everybody get it. Yeah.
Since we've had a number of questions about the indexing,
Yeah.
like how many lines or how difficult would it be to add that indexing?
Well, we can throw it in real fast. There'll be no, here we only have one section, but let's see what it takes. Yeah. So let's go back to the table view. And index is a really bad word to search for in here, because we use index path for everything. So you'll find a ton of them. Let's see. I'll just scan for it. Here it is. Section index titles for table view. So if we implement this,
Just jump in with the
yeah, go ahead.
On the back. So you'll notice we're implementing all of these methods in this class called MyTableViewController, which is a UI table view controller subclass. And the reason we're able to just implement these methods and have them automatically be used by the table view is that one of the things that UI table view controller does is automatically set itself as both the delegate and the data source of the table view that it's displaying. So normally, if you wanted to show a table view on the screen, you'd instantiate the table view, you would add it to some window, and then you would say tableview.delegate equals some object, and tableview.dataSource equals some object. So one of the nice things you get from table view controller is sort of out of the box. It already is the data source and the delegate, and you can just start implementing methods, if that makes sense.
So I'm not going to actually go finish all this off, but here I've got a bunch of letters I'm putting in here. And we'll put a pound symbol in here at the end.
In this array with object right now.
Yep, sorry. Thanks for catching that.
You rehired Troy.
All right. So that causes it to appear. Obviously, when I click on it, nothing happens now because we don't have multiple sections. So let's go modify this and fix that a little bit. We'll implement the table view. Oh, I'm sorry. That's not the. I forget the methods. Number of sections in table view. And we'll return, I don't know, 26 or so. And then, now down here in the self row, we don't actually need to change anything because we only care about the row of the index path. So this will basically dupe our data set 26 times. You can see it's just the same thing over and over. And now as I click this, you actually visually can't see that it's what it's doing here because they're the same. But if I do one more thing, you can actually see what's going on, which is there's a method to set the title for a particular header. So we're gonna grab this guy and throw this in here, and we're just going to return something simple here. Hey. Oh, sorry. Yeah, I just forgot its section. So now as I click, you can see it's actually jumping to the particular section that we're specifying here. Anyway. Yeah.
Thank you, Jason Beaver.
Okay.
Ladies and gentlemen. All right. Okay, here we go. So now I want to give you a little demo of Presence 2. Actually, no, this was supposed to be earlier in the lecture, but we didn't think they're going to make it for the beginning. So welcome, Atlanta Girls School. So I want to give you a little demo of Presence 2, table views, and how to fetch data over the internet. So again, Presence 2 is going to be based on the Twitter APIs, and we'll show you, there's some classes to help you out with actually getting the data from the internet. But everything for Presence 2 you've learned as of today. So. Sorry, Wednesday. But, yeah. All right, so here it is, Presence 2. It's coming up. If your app does this, we'll fail you. Yeah, so we depend on the internet for this one, which is why it takes a little bit of time. But as you see here, we've got a table view with a bunch of different usernames that actually go to Twitter, and they fetch the actual names. So we give them, like, Evan Dahl is edog12345 or something, and it goes and it fetches his name. So all of this is in a table view, and for every entry in this table view, when you click on a cell, let's see what William Shatner has to say today. What's my favorite car? These are actually what he's posted. So thank you for the belated birthday, which is fudge cake. All right. Steve Wozniak says, my iPhone still hasn't replaced my Newton yet. Newton is still a superior platform. Anyone have extra Segway batteries? And what does Shaq have? All right, 45-minute cardio chest workout. Grilled chicken breakfast. So this is your Twitter. This is Presence 2. This is it. So if you get this far, all this data is coming off the internet. We're giving you... for those that are familiar with web programming, there's a JSON helper class that'll go and fetch the data. Oh, we'll talk about that on Wednesday. The class is fairly complete, so I think you can use most of it. But that's it. That's it. So, yeah, any questions on Presence 1 before that has to be due tomorrow, or any questions on this? Yeah. So the question is for Presence 1, is it hard-coded data? Yes, it's hard-coded data. Is it okay to have well, okay, so I don't want you to have different view controllers. I want you to reuse the same view controller and insert the data based on which button is pressed. And again, the hint from earlier in the lecture is for how do you identify which button is pressed is to take a look at the tag property on the UI view. Does that answer your question? Oh, the action methods. Well, yeah, so it's up to you if you want to do 3 action methods or if you want to look at that tag property. Both will do fine for this one. But if, for this assignment where you have a table view, obviously you're not going to have multiple action methods, right? Any other questions? Yeah. What's a Newton? What's a Newton? This is like yeah. It's iPhone 4. It's an old PDA that Apple made in the 90s. Actually, even before the Palm Pilot, it wasn't the first one on the market, but it was huge. It was a big. I mean, it was sexy, but no, it was huge. What's that? Yeah. Right. Yeah. He also lost his belt buckle in one of these classrooms. And anyway. So that's it. Once again, round of applause for Jason Beaver. Thank you very much for coming today. And yeah, we'll see you next week.
For more, please visit us at stanford.edu.